Okay, so welcome back. Now in the previous video, what we essentially saw the relationship between multiplication and addition, and essentially the meaning of multiplication, meaning that we saw that essentially, for example, when you write essentially a 2 plus a 2 plus a 2 plus a 2 4 times, that is equal to 8, and instead of writing this expression, we can write essentially 4 times 2. We can write 4 times 2 is equal to 8, meaning essentially 4, because essentially 2 has been added to itself basically 4 times, right? Now in the previous video, in the end of the video, I mentioned something that essentially a problem with this strategy, meaning that this strategy is not going to help me with, I mean, the strategy has a problem, meaning that you don't really know what is the meaning, essentially what is 4 times 2, because essentially to know what is 4 times 2, you need to do this addition first, right? So you need to do this addition 4 times, essentially 2 plus 2 plus 2 4 times, and then through addition you know that it's equal to 8, and then the same 8 you would transfer it over here. That way you know essentially that is 4 times 2, which is equal to 8, right? And then essentially when it comes to a calculation, like for example 124 plus 124 plus 124 plus 124, for example 4 times, is equal to some number. And then instead of writing this expression, I can write 4 times 124 is the same number. So again over here, essentially I need to add 124 to itself 4 times, and that would be essentially the answer over here. Now doing this calculation over here, you can do it in your head in a couple of seconds. You know that essentially 2 plus 2 is equal to 4, 2 plus 2 is equal to 4, 4 plus 4 is equal to 8. And so then as a result 4 times 2 is equal to 8, right? But then 124 plus 124 plus 124 plus, that's not something you can do in your head. Even on a piece of paper you need to write it. I mean you do need it on a piece of paper, and then you need to write it as 124 124 124 124, and then essentially add all of these together, and then you have essentially some answer over here. The answer, you have to bring it here and also bring it here, and then that becomes your answer, right? And also this number of course can grow any larger and larger all the way up to infinity, meaning that for example instead of 124 you could have essentially 1 2 3 4 5 6 7 plus 1 2 3 4 5 6 7 plus all the way up to basically 1 2 3 4 5 6 7, and that would be equal to some number x. And then we could do this for example, I don't know, 526 times, right? And then this calculation would be then essentially 526 times 1 2 3 4 5 6 7, and that's the same number x. And then to solve this problem, I would have to write essentially 1 2 3 4 5 6 7 plus essentially the same number plus the same number plus the same number all over and over again, 526 times, and that would be the answer here, which takes an eternity to calculate. Some essentially you would have essentially this x over here, and then this x you would bring it over here, and then you would bring it over here, and so of course this is not, I mean it's not easy to work with this whole thing. So we need to find a solution basically. The solution that has been found over time, which is also an interesting solution, is essentially nothing but the long essentially multiplication algorithm, right? In the long multiplication algorithm, what we have done is essentially the following. It's actually a very neat solution, and then later on the same solution has been given to, I mean, by the time there was no computer, I mean, there were abacuses, and then after the abacus there came essentially the mechanical abacus, and then after the mechanical, I mean, all the operations were actually kind of programmed into gears and things like that, into mechanical machines. And then those mechanical, and once we had electricity, those mechanical machines were essentially run by electricity. And then once we had essentially then came essentially the electronics and that sort of thing. Then there were these vacuum tubes. Still there was no computer in the sense of the computers that we have today, but they were these vacuum tubes. Using the vacuum tubes, we built some very primitive computers. They needed, of course, a whole lot of power, but they could compute a couple of things. And then essentially the whole thing was programmed into those machines with vacuum tubes. And then came the transistor, and then came basically the computer that we have today. Then came the chip and the CPU and all of those things. And today essentially you have this small calculator over here, which is a scientific calculator. It calculates almost everything that there is in essentially in mathematics, basically. Okay. But from the very beginning, essentially the solution that has been found essentially to solve this problem is very easy. Is a very essentially interesting solution. Meaning that the solution is that we came up with the long multiplication algorithm. In the long multiplication algorithm, suppose that I write essentially a 527 plus a 527 plus a 527 plus a 527 is equal to some number, right? Now this is 527 plus itself 4 times, right? So then essentially logically that means essentially 4 times essentially 527 is the same number x, and I want to calculate it. Now the only question is, how do I do that? And just like, for example, the addition algorithm, we have we invented the multiplication algorithm. In the addition algorithm, we said that, for example, a 527 plus a 527, for example, let's say only 2 times, just add it to itself. We know that essentially 7 plus 7 is equal to 14, right? Based on the tables that we have, right? And 14, we have one carryover, that's essentially 1 plus 2 plus 2, that's a 5. And then 5 plus 5 is equal to 10, so that's 1054, right? In the exact same way, we have the long multiplication algorithm. So, for example, if I were to write 527 times a 4, and that's a multiplication, then basically we will take a couple of things here into consideration. So we have 500. So we have, let's say we have 527 times a 4, right? So what we will do here, basically the way that we calculate it, I just want to show you a couple of details of this process. Later on, we will bring in essentially all the details that are necessary. So I will calculate essentially 4 times 7. Let's make the assumption that I know that essentially 4 times 7 is equal to 28, and let's say that I have essentially all the multiplication tables of all the numbers 1 through 9. I have written it down on some pieces of paper, and I have access to those, or essentially I have memorized them, something like that, right? So 4 times 7 is equal to 28. Now for the reasons of the place value in the number, of course I cannot write the whole 28 over here, so I write the 8, I keep the 2 over here on the side, right? And later on I will show you essentially why exactly we do this, because it's important to know, but not for now. Now 4 times 2 is equal to 8 plus 2 is equal to 10. Again, I write the 0 and I keep the 1, and 4 times 2 is equal to 20 plus 1 is equal to 21. And so then we know that essentially 527 times 4 is 2108, or 2108. Right? Now if you paid attention to the process that we went through here, first of all, you need to know essentially all of these different multiplications of simple numbers, meaning essentially what is 4 times 7, what is 4 times 2, what is 4 times 5. Now this problem we can simply solve by writing down the multiplication tables, and once we work with them for a short amount of time, we will learn them by heart. That's not a problem, right? And then there is also essentially the place value in the number, meaning that in the number 524, essentially we have the ones place value, the tens place value, the hundreds place value, that we have already learned, and then we will use it later on as well. In the number 4, essentially we have only the ones place value, and then once we essentially go through this operation, we take all of those place values into consideration by essentially bringing these essentially the 2, the 1, and so on and so forth to the side, and then adding them back in, and so on and so forth, right? So that means that essentially now we have actually solved the problem of multiplication. The only thing that we need to do, for now at least, is essentially to know what is essentially these computations, like for example 4 times 7, 4 times 8, 4 times 9, and all of these. You have to just calculate them once manually by hand, and then we can keep using them in this algorithm over here, right? And of course it's not really necessary to keep doing this kind of calculation. I mean, even this kind of calculation we don't have to keep doing it manually for our whole lives. Then basically what happens is that once you've learned essentially how this works, then you can give it to a machine to do it for you. Meaning that today essentially we have, I mean, even 20 years ago we didn't have all of these fabulous mathematics tools, because we didn't have good computers still yet. But today we have great computers with great facilities, RAM, CPU, and that sort of thing. So now we have written essentially all of these great programs for these computers. They do graphs for us, they do all kinds of calculation. So essentially, ultimately the same operation we can give it essentially to a computer, and the computer will be able to do the whole thing for us without any problems. But of course we need to essentially learn all of these things so that we know essentially how the whole thing works, so that we know essentially how mathematics works, right? So now essentially what we need to do is that we need to go through essentially all of these multiplication tables for all of these different numbers, like 2, 3, 4, 5, 6, 7, 8, which we will discuss in the next few videos. Thank you.